Okay, this is a movie called Significant Figures, Scientific Notation, Accuracy, and Precision Review Movie 2, as opposed to Review Movie 1. Now, there's going to be several parts to this movie. The first part, you're going to be given a measurement. Now, you don't know where the measurements came from. You don't know what the instrument looks like. So you need a set of rules that lets you figure out which digits in the measurement are significant and which ones are not significant. Why is that important? Because in a measurement, there might be, depending on how it's expressed, significant figures and insignificant figures. The significant figures are the ones that came from the instrument, and those will help you define precision and accuracy. So those are important to know. You need to know where the significant figures come from. That's where everything starts from. You can convert things into scientific notation. That will be another part of the film. And then you're going to have to take a measurement and interpret, well, what's the accuracy of that measurement? And then what's the precision of that measurement? So you're going to be given a measurement. You have to find the number of significant figures. You have to convert to scientific notation. You have to be able to determine accuracy and determine precision. All right, so let's get started, and I'll let things run. I'll give very little narration during the film, and it will give you a chance to stop, pause. I uncover 10 or so values at a time, and it allows you time to determine the number of significant figures or whatever the case may be. So, good luck. Let's get started. So, how many significant figures are in each measurement? Okay, so 1, 2, 3, 4. You know that all non-zero numbers, all non-zero digits are significant, so there's going to be 4 there. There'll be 3 in the next one, etc. So get out your rules and be able to do these, okay? And so what I'm going to do is I am going to just let things run, okay? All right, I'll see you in a little while. All right, so that was 60 problems, 60 measurements, and you figured out the number of significant figures. Now what we're going to do is we're going to convert these to scientific notation. Then we're going to determine the accuracy. Then we're going to determine the precision. So I'm going to uncover the first 10. And then at that point, I'll determine what is the scientific notation. Now, remember scientific notation. It only uses significant digits in order to write it. So you'll take it out of this form in this column that's being uncovered, and you'll put it into scientific notation. Remember to correct for the base 10 for the place value. All right, here we go. The first one. What do you think it would be before it shows up? Okay, 1.234 times 10 to the third. All right, so now you're practicing. Okay? All right, good. So I will leave you, and there's going to be 60 of these problems to do, and so it'll take quite a while for it to happen. So you can put it on pause, skip around, and see if you can do the practice. Okay? See you in a little while. All right, now the accuracy is actually simply the number of significant figures. That's really what the accuracy is. The greater the number of significant figures, the greater the accuracy. So number 1 has 4 significant figures, number 2 has 3 significant figures. So if you're going to multiply, for instance, two measurements, one has 2 significant figures, the other has 4 significant figures. You would round to 2 significant figures because the rule says when you multiply or divide measurements, the answer must have the same accuracy as the least accurate measurement. Okay, so you need to be able to think in terms of significant figures for accuracy. Precision is the lowest place value, smallest place value that has a significant digit in. So number 1 is ones place. That number 1, that means ones place, tens place. So it's plus or minus. I leave the plus and minus out. So the uncertainty, the precision. So it's the smallest place value that has a significant figure. So look at number 7. That would be hundreds place. Number 8 would be hundreds place, etc. So if this is one of the last of the movies for measurements that you've watched, you should be fairly comfortable by now. This is actually should be one of the final of the films that you've watched. And again, you should be familiar with significant figures, scientific notation, accuracy, and precision. All right, have a good day.